fix you guys get?
1.16 times 10 to the negative 10.
Yeah, that's beautiful. That's exactly right. Yeah, we'll go with about 1.2. I'm going to round it. Times 10 to the negative 10th meters. How many people got that as the wavelength? Okay, yay. Well, here's something I want to remind you of. Do you remember the angle of diffraction, where, you know, the location of our interference fringes when we put light through diffraction gratings? This was the formula we dealt with. Sine of theta equals m lambda over d, right? And if, you know, lambda over d, if lambda over d ends up being like 1/2, then your angle of diffraction is going to end up, well, it's not, well, I'm thinking of diffraction gratings, but just diffraction itself. When you have a wave going through an opening, and then the wave ends up kind of going like this sort of thing, and so you're able to say, okay, this is the angle of diffraction, then it ends up just being sine of theta equals lambda over d. That was the relationship we got with diffraction when we first learned about diffraction. When I'm putting waves through a single opening, how much of the wave comes out and how much is it curved and all.
Is it hard? Is it hard?
Well, look at this number, wavelength. Did you know that that number is comparable to the interatomic spacing of a crystal? That is, if you have a crystal lattice structure, okay, those spaces are comparable to that number, which means when you shoot electrons through that crystal lattice, those electrons are going to behave like this. They're going to behave like a diffracting wave. And because they behave, when they emerge, they behave like diffracting waves. That's why you get your interference fringes. Yeah, so de Broglie was right, or de Broglie was right. You know, these particles do behave like waves. Yeah, the wavelength is really small, but the particles themselves are really small. And you can shoot them through really small openings, and they act like waves. Particles act like waves. But I'd like everyone to do the next equation. Do part B, a baseball moving at 30 meters per second. Please find me the de Broglie wavelength of the baseball now. Just use that same formula.